Hi, hello all. 3D printing empowers us to create custom structures and accessories for our daily life. Most of us download models to print or we design them. In this video, we are going to discuss about designing models but not using CAD while by topology optimization. As you can see here, we have a slab that is being supported by two legs and some load or object is being placed on the slab. And the job of these legs is to transfer the load that is being placed above the slab to the wall to which it is clamped. So now I can download an STL from internet, print it and use that as my leg. If the leg fails, if the leg could not carry the load, then I'll have to find a different STL, or I can increase the dimension of this thickness of this leg such that it can carry the load. If I couldn't find any STL in internet, then in that case I'll have to use a CAD software, draw my own model, my own leg. In that case, what should be the shape of the leg? What should be the dimensions? I'll have to go for a trial and error method. So this is where topology optimization. This problem is what topology optimization solves. So topology optimization determines the load path, how forces travel from the point of load down to the support, and keeps material only along that path, removes the rest. For instance, here we have a slab supported by two legs, and some load like a book or a computer will be placed above the slab, and that load will get transferred to this leg down to the ground where it is supported. So for this leg, the top face is the load face and the bottom face is where it is supported. Now, topology optimization finds the path along which the load is transferred from the load face down to the support and keeps material only along that load path and removes material elsewhere. So we get a lighter structure and it efficiently transfers load. As you can see here, we have the slab and there are several objects placed above that slab, and this leg transfers the load at the top down to the support at the bottom efficiently without failing. At the same time, it is professional looking, it is good looking.
Now, okay, so we shall solve a slightly different problem using Amoc. The same slab with two legs, but the slight change here is instead of the legs being placed on ground, they are clamped onto the wall, and we shall try optimizing the shape and topology of these two legs. We shall consider that the slab that is placed on this leg has to carry load that is an object which is being placed on that slab is approximately 10 kgs. Now the top is the load face, and the load from the slab gets transferred onto these legs. Instead of the point of contact being the entire face, I have chosen two isolated regions which are the point of contact between the slab at the top and the two legs. Okay, so these are the load faces, and the leg is clamped onto the wall, so this is the support face. Now, the optimal topology that is being given by Amoc looks like this. So here, the tool finds the load path from the load face to the support face, keeps material only along the load path and removes the rest. Okay, how much of material has got removed? That is defined by the volume fraction, which is also an user input which I have given. So I have selected a volume fraction of 0.4, which means 40%. So I have asked the tool to keep 40% of the initial solid material while remove 60% of the unwanted material. So the tool kept the material of up to 40% of the initial volume that lies along the load path and removed the rest. Okay, so why should I keep it 40%? Why should I not further decrease it to 30%, 20% so that I will have a lighter and lighter leg? That is governed by the failure strength, because as I keep on removing material, the material which is currently present gets more and more stressed. What is the maximum stress that this material can undergo is determined by this material's failure strength. So here the material I have chosen is PLA, which is widely used for 3D printing, and the stress this material undergoes cannot exceed the failure strength of PLA. So here we have a term called safety factor, which compares the stress this material undergoes to the failure strength, and it gives a value of above 1. Actually this is way higher than 1. So this structure is safe, it can carry a load of 10 kg and the volume fraction of 40% is fine, and the safety factor is much higher than 1. Okay, let me try a volume fraction of 15%. So now I have an even lighter, thinner structure and which has material along the load path, and 85% of the unwanted material has got removed. And still the safety factor is higher than 1, so the structure is safe. We have not used a CAD tool to draw a leg. We have not downloaded an STL which we have to test whether it will work. We have to go for a trial and error, change in dimensions, change in no. We did not do any of this. We just gave our conditions like the load that will be present on the slab and what is my desired volume fraction, and I get a topology. I can just print this topology. I can clamp it onto the wall. This ensures that it can carry a load of 10 kg. There is no need of changing of dimensions or shape. What all we saw here is topology optimization keeps material along the load path, removes material which do not lie along the load path, and how much of material it should keep and how much it should remove depends on the volume fraction which the user decides, but the user cannot keep on reducing the volume fraction because it is governed by the failure strength of the material also. So I encourage you all to try come up with your own design. There are demo videos in Amoc. You can go and have a look to guide you on how to use the tool. I will also come up with more videos on different use cases where you can use topology optimization used for functional prints. See you in coming videos. Bye.